Okay. Yeah, hopefully you don't get an ad. It's very, very hard to tell whether internet issues like this are related to like my computer components. We could have a failing network component. It could be the internet. It could be OBS, the software. It's really, really hard to tell what is causing these issues. Hopefully we'll be able to get it fixed. I should probably invest in a new laptop. Okay, can everyone see me? Everyone good? Uh-oh. Are we connected? Are we connected? My one computer is working and the other computer is not working anymore. Let me see if I can read chat on my Twitch app here. Okay, it looks like, are we live? Chat, can you give me a sign if we're live? Can you give me a sign, chat? I'm looking at my chat on my phone right now. Okay, good. All right, let's get back to it. The show must go on. Okay, so what I'd like to do next is I would like to go through a little bit of a systems design expo, which is going to take us through some interesting topics, including delegates, actions, callbacks, the observer pattern, and just kind of the general topic of systems design and how to integrate different pieces of a system, isolate the pieces of a system, mock other pieces, get them working one by one, and integrate. So let's go ahead and try it out. So here is our objective, okay? You have implemented, you've released a game. Congratulations. It did extremely well in the marketplace, and there are lots of people who are your fans now. You start getting feedback, which is always good. You get feedback from the release of your title. And the feedback you're getting, though, is that sometimes players don't always know what the controls are. Sometimes they don't really understand the lore of the game. Sometimes they don't know what to do. They don't know what their high score is. And, it's just a bit of a bummer. So your team, your design team, comes up with a plan. We need a new technology that's going to let us send a message to the user. Okay? A small message to the user at any time. Now, it needs to work at absolutely any moment, and it needs to be very easy for other programmers and systems to use. And so here's what you end up doing, right? You end up creating what's called a toast. A toast is built in, it's a lot of places actually. The Android operating system and iOS operating systems have toast systems. And essentially it's this little message, right? This is message that's system standard that you can just make appear in your app. Games like Spelunky will often implement their own toast systems, like what you see on the bottom here. A wolf howls in the distance. And it's really good for just getting some information quickly to the player. The game that I worked on had a slightly more complicated toast system, where it would actually store previous messages and make them fade out as they move up the screen. So you can see the toast system kind of on the side here. But anyway, so toast system. The requirements is that the user must be able to provide a message of some sort that gets shown to the player. It must be super easy to provide this message. In fact, anywhere in the code base, we should be able to make a function call and boom, just have our message work, okay? And it always has to be available. It doesn't matter if we're at the end of the game. It doesn't matter if we're in the credits on the title screen. During gameplay, it doesn't matter. The toast system should always work, okay? Now, we're going to have 3 phases of development here. The first thing we're going to do is we're going to mock the UI. We're going to create a toast message that isn't hooked up to any sort of logic. And then, once it looks okay, we'll start to add it to logic. We will basically fake the logic. We'll fake our own requests in order to test the system out. And then eventually, when everything is working with our fake requests, we'll integrate it into the rest of the game, and we'll have the rest of the game use our new system. Okay? So let's talk a little bit about system design. Typically, right, you've got inputs and you've got outputs, right? Things the system takes in and things the input does or outputs. Now, you can consider an example of this, a player manager. So this player manager, it is required, and its basic job is to spawn and manage players, okay? So in terms of inputs, it might take in a player number. So do you want player 1? Do we care about player 2, 3, 4? And a spawn location that will determine where the player gets put. And the output of this system is going to be, hey, you simply spawn the player indicated, the player number indicated, at the right position indicated, okay? Now, this might seem super simple to you, but it might not be. There could be different meshes, 3D meshes that we need to load depending on which player is being spawned. Maybe each player has custom outfits, custom characters. Maybe the spawn location that gets sent to us is actually outside of the map. Maybe there was an update or something, and a save file now has old data that stored a player being at a no longer valid location. The player manager has to take all of these inputs and just has to make it work, okay? Or the player system needs to provide some sort of error message so that the player can help it out, all right? And that is not, that's not going to be super straightforward, even though it looks straightforward right here. One thing that we always try and do when it comes to inputs to various systems is we try and constrain their interfaces as much as possible, okay? If you think about it, it's one of the whole reasons that we have private versus public in C++. In C++, in object-oriented programming, you typically want to adhere to the principle of least privilege. You try and restrict access as much as possible so that people who don't need to use an API aren't able to use it. People who don't need access to a piece of data can't access it. This is why if a piece of data inside of an object, like that float health, isn't important to external systems, you make it private. Because you don't really want some random system in the corner of your code base to one day just decide it's going to change the value, right? That might cause you to be like, wait, what? It changed? Why did it change? What it's doing that? It did that at the wrong time. Oh, it's causing bugs because I was dead, but then it decided to change my health back to above 0, and now I'm, all right. That's why we constrain things as much as possible. So we're going to constrain our interface. This system is going to have like one function call, and you have to use that function call. It's going to have only 2 parameters, and no matter what parameters you give, the system is going to not crash. It's going to do the smartest thing possible with those inputs. That is your objective anyway. You want your inputs to your system to be as simple as possible so that your teammate can't mess it up, right? The system has one function call. Your code completion is going to show it to you. It has 2 very obvious parameters. There's no way you can mess this up, all right? Even if a new intern comes onto the team, they find this function call, they're going to use it correctly. They're not going to generate bugs. Okay, let's talk about a toast manager. This one is even simpler, all right? The only input you're going to be able to have to the system is a message, a single string. Now, we could change that. We could change that. We could let users add an integer, send an integer in that determines how long we show the message. We could let the user specify a color. So what color is the text going to be? A text effect. How the character is going to whoosh around and pop and disappear, right? But for now, to keep it simple, we're gonna just let you send in the message. That's it. And then as output, we just simply show the message to the UI in a nice, juicy, and polished looking way for a certain amount of time, then we're done, okay? So where are we gonna begin? Well, systems can be slightly intimidating when you view them as a whole. There are all these things you need to do, but if you break it down, they can be really, really darn simple, okay? So we're gonna break these things up. We're gonna work on the UI, the system itself, and then integration and sending to the system in their own small pieces, okay? When you implement one piece, you mock the others. So for instance, while we're working on the UI, we're gonna mock the actual system and requests to just basically, we're gonna create cheat codes that send in requests to make the UI do stuff, okay? All right, let's get to it. I'm tired of waiting. Let's go in and we're gonna open up that Unity project. Let's go to Unity, Let's bring the web captioning back. Okay, 494 toast. Ooh. You know, it's much more enjoyable to lecture for 4 hours straight when it's in person and you're walking around and you're gesturing and get the blood pumping, you know, and it's yeah, it's a little bit. I don't like to sit for 4 hours straight, though I do it a lot for programming. How are your other classes going, everyone? Are there any classes that are really, really picking up, very tough right now? I need to clean this project up really quickly to make sure that our systems from last section do not get in our way. Here we go. Good. Remove Toast Manager 2. Uh-oh. I sat literally all day yesterday. This is my only hard class. That's probably a good decision on your part. Very wise. Same. By design. Yep. Okay, we're going to remove that component there. And we're going to also get rid of this other Visual Studio window. We don't care about Toast Manager 2. That was from last section. Or Toast Manager 1. Or Game Manager. Okay, good. Okay, so what I'd like to show you is I'd like to show you what the final result of our Toast system is going to be when it's finished. This Toast system is very straightforward, and if you're not giving a lecture on it and explaining it, you can build this kind of thing in about 10 minutes and have it be very hardy and work very well. But here's the deal. In this system, whenever you get a high score, it is going to bring in that toast at the top. And it's going to give you that little message. When you do not get a high score, it is going to not give you that message. But the cool thing is, no matter how many times you send this message in, it is always going to work. You can queue up messages if you want to. Cool. Okay. So let's get to it. So right now, I'll prove to you really quickly that we have the base kind of Flappy Bird experience going on. Oopsie. Unity messed up a little bit here. Oh boy. Okay, there we go. So let's just show you the vanilla Flappy Bird. Okay, so we can fly, and we can go through these pipes. Uh-oh. It looks like maybe this is okay, let's see if we can debug this really quickly. So program, UI behavior, graphic text, game manager 81, game manager 81. It thinks this is bogus right here. Score text is null. Game manager, let's see if we can find game manager. Game manager, is this null? Score text is fine. Score text is just fine. So I'm curious why it is null. Let's make sure the score text is still fine when we start the game. Now, still an issue. So you know what I'm going to do? This isn't relevant to today, so I'm going to fix this overnight, and on Wednesday we'll finish up with a fixed version. But anyway, what we want to do first is we need to get the UI mocked, right? We can play the game and we can see it basically running, but we'd like to be able to see our UI. Okay, so when it comes to making UI, it always deals around a canvas. It always revolves around a canvas. A canvas game object is very special. It's a game object with a canvas component. Now, everything related to UI needs to be underneath, parented to a canvas game object. If you click on the canvas, right-click, you can come down to UI, and you can choose what kind of UI element you want. A good place to start is just about always a panel. It's simply a rectangular object that you can color if you want to. So let's go ahead and name this panel. We're going to call this the Toast panel. And we can, if you look in the inspector of any game object that is related to the UI, what you'll notice is that there's a rect transform. There's not a normal transform component. However, see a normal transform right there. However, they still have the same essential goal. A rect transform component is all about how do you position, how do you anchor this game object? How big is it going to be? How is it going to rotate? Now, with UI and rect transforms, the first thing you usually want to decide is, what do you want to anchor this UI element to? Do you want to anchor it to the side of the screen? Which side? Do you want to stretch it, anchor it to all four corners? Do you want to anchor it to the center, or the bottom, or the top? We want to anchor it to the top. So we'll make it anchored right there. And we can adjust its width and stuff, make it a little bit smaller, bring this way down. Okay, you know, let me just type it. Let's make it like 300. That's fine. And the height should probably be something like 200. It's too thick. 150. How about just 100? Okay. And we want this to be at the top. So we anchored it to the top, but it's not there. We need to actually adjust the coordinates here, the x and y position. So that y is negative 540. If you look closely at it, it's negative 540. That's telling us that this element is negative 540 units, pixels, below where it wants to be. If we set this to 0, it'll go to its origin, it'll be right there at the top. But what's weird is that it's kind of half on our screen and half off. We want to just kind of sit half off the top of our screen, or entirely off. So what do? Well, we could move it up a little bit like this, but that's kind of lame. What we want to do is we want the center of our object, the pivot point of our object, to not be at the center. We want it to be at the bottom. Okay? We can adjust that pivot point via the pivot area right here. We'll set it to 0, which says put it at the bottom instead of the middle. And then we just adjust it back to 0, and we're at the top, right? Now every coordinate is calculated relative to the bottom of our element instead of at the middle. Okay, and that's great. We can't see our UI element, but it's still just up there. I'm going to adjust the color real quick. Unity is so weird lately. Okay. I'm going to go ahead and save. And then what we need to do is we need to add some logic here. Actually, we need to add some text first. So let's add some text to this UI element. We'll right-click on it. We'll go to text. That adds a text game object. Let's call this toast text. If we zoom in on this object, we'll see that it's kind of like, it's not using the full space here. It's kind of poorly positioned. So if we think about this text, it probably wants to take up pretty much all of this panel. No matter what size it is, it wants to use that space. Its parent, the toast panel. So we're going to anchor it to stretch to all four corners. We click on the anchor position. The stretch to all four corners button is down here. And okay, well that did nothing. It never does anything. Then you need to adjust your coordinates. Okay, look at that. Now our text is taking up the entire area of our toast panel. But this also looks kind of crappy. Okay, it's not very great. So what we'll do is we'll say, you know what? We want to be 20 pixels from the left side of our parent, 20 from the top, 20 from the right, and 20 from the bottom. Now we've got this nice even spacing on all four sides, and we want to align our text to be in the middle, and then this is too small. So what you can do is you can say, hey, text, just resize yourself automatically for me to be the right size for the space you're in. We'll click best fit. Okay, best fit causes it to get bigger, looks good, and yeah, there you go. What's cool, oh my gosh, it's not, this UI isn't working. Talk about, I do not think OBS is the only software giving us trouble today. Okay, so now what we need to do is we actually need to make this appear. We want this object to do like, we want the panel to come down at the right time and kind of show itself, right? And ideally customize this message. So it's time to start writing some custom logic. We're going to go to our canvas and we're going to create a manager class. We're going to call this Toast Manager 3 because we've already created two other ones. Okay. So Toast Manager 3. Well, what do we need to do? Well, the first thing the Toast Manager needs to manage is where is the Toast button, right? I mean, where's the Toast panel? Is it hidden? Is it visible? So let's take down some locations here. If we go back to Unity and we kind of move our thing around, we can see that a really good hidden position is just 0, 0, right? X0, Y0, that's hidden, that's off screen. However, if we want to bring it down into view, we can see that -150 on the Y is really, really good for that. It just comes right into the bottom, at the top of our screen here. So -150 it is. Let's go ahead and create this hidden position variable. It's going to be vector2.0. How about a visible position? It's going to be new 0 on the x-axis, -150 on the y, okay? And in terms of logic, let's just fake it for now, right? We're going to mock our requests. So let's do this. Every single frame, if input.getKey, so if the user is holding down which key, how about spacebar? Then what we want to do is we want to move our toast to be visible. Otherwise, we want it to be invisible. However, we need a reference to it to be able to actually move it, right? Okay, so let's create a public variable here. We're going to drag that panel right in. Now, we don't want to transform, we want to rect transform. So we're going to call this toast panel RT, standing for rect transform, okay? And we can move it. We can set its position. Here's the thing you just need to unfortunately memorize. When it comes to UI elements, you almost always want to adjust their anchored position instead of their actual position, okay? Anchored position is the value that you see in the inspector. If you look at the coordinates up in the top right. Location or position is something else entirely. If you forget and use position, you'll get really weird results, okay? Until you remember that you should use anchored. Okay, so if we're holding space, we want to go to the visible position. Otherwise, we want to go to the invisible position, okay? All right, and that's pretty much it. Let's go ahead and make sure this works. It's not a ton of code, but we do need to remember to drag in the proper panel. So we've got our new toast panel RT variable. I'm gonna go ahead and drag that in. Then we'll play our game and see what happens. Okay, so pretend that we're gonna get a point here. So we're gonna go through, we're gonna get a point and hold spacebar. And there it is, you can see it. And done, and hold spacebar. There it is. There's our toast in action. We're faking it, of course, but it sort of looks the way that it should. So now we do not want to fake it, right? We don't want to fake it. We want to be able to provide a request to the system and have it show the, move the toast panel into view, show a message for a little bit, and then leave, okay? If you think about this process, it's very temporal, right? Something happens over time. And whenever anything happens over time, a prescripted sequence of events over time, you probably want to think about coroutines, okay? So let's go ahead and create a coroutine. Let's call this process request. Process request. And what is a request? Well, a request is basically a string, okay? Now, what happens when we do a request? Well, we want to quickly make our panel visible. We want to actually set the text first, though, don't we? But we'll get to that in a sec. To do set text. We want to move ourselves in. We want to wait for a little bit of time. Yield return new wait 4 seconds. How about 2 seconds? And then we need to move our panel out. We need to make it go away. Okay, now how do we set the text? Well, the first thing we need to do is we need the text data type, the text component class. So we need to have a UI using statement. This will give us the text class, public text, toast text, okay? And now we can drag that toast text in. Now that we have a reference to it, we can actually set the text. So text.text equals message, okay? So we need to then call this, let's try if input.getKeyDown, keycode.space, we're gonna send in a message. Start coroutine. What kind of message do we want to send in? Let's just send in a random number. How about that? Actually, let's dress it up a little bit. Let's make it a little bit more authentic. New high score. There we go. Oh, actually, sorry, I messed that up. Hold on. Hold on. There we go. That should be better. Okay, so whenever I press the space bar, we should process a request of new high score plus a random number, and that means we should set the text, make that text visible, wait for 2 seconds, and then make it go away, okay? We need to drag in that text variable, though. Yeah, not getKey. We used getKey down because I only want that to execute once on the exact frame at which I press the key, okay? So let's go ahead and go to Canvas. We will drag in our toast text. Oop, there we go. And we'll go ahead and see how it goes, okay? Oh, did I not do getKey down? Sorry, Ish. What'd I do? Ah, you're right, getKey down, thank you. Yeah, what would happen is it was gonna look horrible if we let that stay in there. The thing is, we would launch one coroutine for every single frame I had been holding down space, which would quickly cause the visuals to go super glitchy. Ah. Oh my gosh. All right. So we're flying, and I'm gonna hit spacebar. Space. Okay, it shows us a random number for a couple seconds, and then it's gone. Press space. Shows us another one, then it's gone. Press space. Another one, then gone. All right. Good. It worked. All right. This is good, but it's not very fancy, is it? Okay. So if you remember from our coroutines lecture, we actually had a library that was coroutine, move game object over time, or move transform over time. And what it did was it calculated a variable called progress that went from 0 to 1 over a certain duration of time. And because of that, we were able to linearly interpolate our position from one location to the next, essentially creating a linear animation. We're going to do the same thing here, okay? We're going to replace this line and this line with lines that progressively take our object from one location to another instead of just warping us there. It's going to look a lot nicer, okay? So let's go ahead and comment that out and we'll do it. So let's start. Float initial time equals time.time. Float duration seconds, oops, equals, let's say this needs to happen in like 1 second, okay? Let's calculate our progress. Our progress is going to be the current time minus the time that we started this process divided by the duration of that process, okay? Now, if we keep calculating via this line right here, the progress variable is going to go from 0 to 1 over the course of 1 second, okay? So let's go while progress is smaller than 1, we want to recalculate progress because time is advancing. We need to yield return null so to let the rest of Unity run. And we need to calculate our new position. So our new position, let's do, hold on. Our new position is not going to be just warping to the visible position. It's going to be linearly interpolated between those two positions. So vector2.lerp unclamped. Let's go from the hidden position to the visible position over the time as progress goes from 0 to 1. Okay, looks good. Let's verify that this is correct really quickly. We should see our box, instead of warping there, we should see it slowly come down and then hang out and then warp back, okay? Let's see if that's how it happens. Okay, we're going, I hit spacebar and it comes out. Nice. All right, it worked. Good, it worked just like we expected. Let's go ahead and do essentially the same process. This is something you should put into a library, but for the sake of time, I'm gonna do a copy paste. I apologize. We just had a lecture on why copy and paste is bad, but we're gonna do it anyway, okay? So we'll calculate progress again. It's essentially all the same, which is why we should put it into a library. It's essentially all the same code. However, we're going to go from the visible position to the hidden position instead of vice versa. Okay, cool. So now that's going to work really, really well. However, we have a problem. This system is really, really vulnerable because while it will work, while you can call and request that it show a message, what happens, chat, if you press spacebar while you're already showing something off? What happens if we ask it to do multiple requests at the same time? Uh-oh. What do you think is going to happen, chat? I'll give you a hint. It's not gonna look good. It's not gonna go well. I'll hit space 2 times. Space. Ooh, look at that. It's all glitchy. Space. Ooh, that doesn't look good, does it? It like snaps and glitches and it changes what text it's showing, and it's just not good. Okay? Well, if you think about it, our system is really vulnerable to the situation where multiple systems make multiple requests around the same time. Ideally, it should just work, right? If you make a request to the system and that we're already processing a request, then we should just wait. We should process our current request, and when we're finished, we should grab the next one in the queue, okay? And so, let's go ahead and do that. So, in order to process a queue of requests and store a queue of requests, we need to actually have a queue data structure. So we're going to have a queue here, and what are our requests? Well, they're string values. So let's call this request queue. Yeah, and we need a way for our external systems to make a request. It has to be publicly, globally available, and super easy to use. So we'll make it public static. Remember, public means that other things, other systems can see it if they have the instance. Static means that this is not associated with an instance. It's associated with the class, okay? So public static void request. And you need to send in a string message. And when we make a request, when anyone makes a request, we need to put it onto the queue. Unfortunately, though, we have a problem, okay? Because we can't use the request queue. We can't just pop it onto that queue like this. Why? Because this is an instance variable. You do not see static here, okay? Which means every time you create a new instance of the Toast Manager class, there will be a new request queue. As in, if you have 3 Toast Managers in your game, then you have 3 request queues. So with this function call, we don't know which instance you're talking about as far as which request queue you want to put in. You want to put this message in, okay? So what do? This is an issue of we have a nice public static function that provides access to an API really easily. You can literally just do toast manager 3.request from any place in your code base, and that will just work, okay? But what we really want is we're never going to have more than 1 Toast Manager in our game. So we actually should know which instance we want to put into the queue. So what we can do is we can use a design pattern that's called the singleton. Has anyone heard of the singleton design pattern? Chat? Here's how it goes. Here's how you use it. The first thing you do is you create a static variable that represents the one and only instance that's allowed to exist, okay? Toast Manager 3, we'll call this instance, all right? Now, when we start up, we actually have to claim that instance, or we need to go away. So when we launch the game, we say, hey, if, oh, I misspelled that, didn't I? Cool. If instance is not equal to null, which means the instance has been claimed, it has a value, and instance is not equal to this, then we know that there already exists a Toast Manager 3. So we need to destroy ourselves and stop executing code, okay? Otherwise, if we didn't do that, there would be multiple Toast Managers, and the singleton would be violated. So, however, if the instance is null, then we can go ahead and become the instance. So instance is going to be us. and we're not going to destroy ourselves when the scene changes and the game restarts, okay? This is the basic way to implement the singleton pattern in Unity. It's a little bit confusing at first, but if you download this project from the lecture notes, all of this is super well documented and will explain what each line does again, okay? And why it's there. So the important part, though, is that as soon as the game starts, this instance variable is the instance of this class, which means we can use it to grab the request queue. We can do this, okay? Instance.request queue, boom, we're done. We're good. It works, all right? So every time someone calls this function, we're going to add a new We're going to add a new message to our queue here. So we're going to call request with a message. Let's call hiya, and then we'll add a random number so we can tell that it's a new message. Cool. Okay. So, however, we actually need to grab things out of this queue, don't we? This is just debug mock integration. Okay? What we need to do is we need some logic that says, hey, if you have a request in your queue and you're not processing one right now, grab a new request and process it. So here's that logic. If request queue has something in it and we are not processing request, and this is a Boolean variable that we need to make. So let's go ahead and make it. Process request, let's call bool processing request equals false. As soon as we start processing a request, we say, hey, we are processing. As soon as we end processing a request, we say, hey, we are no longer processing something. Okay, now we can go ahead and use it. So if we have a request to process and we're not processing anything, then let's go ahead and process something. Let's go ahead and grab that request. So that's going to be a string, new request to process equals request queue dot dequeue. And then let's go ahead and launch that coroutine. So start coroutine. And that coroutine is going to be the new request. There we go. So let's go ahead and make sure this works, all right? We'll go ahead and, I guess it compiled while I wasn't looking. I'm always spooked when Unity doesn't take a long time to compile. It's very, very scary. Sort of like when the code works the first time, you know? It's very spooky. Okay, what I'm gonna do is I'm gonna press the space bar 3 times. And what we expect is to see 3 different messages that all look great. 1, 2, 3. So we've got hiya 88. It then goes away, and then comes back immediately. Hiya 99 and hiya 86. All right? So do you understand how much of an upgrade the system just got? It is now impossible to defeat the system and make it glitch out and do weird things by sending too many requests in too close a proximity. Okay? So our system is now hardy and defended over time. All right, and essentially all we needed to do was take the coroutine that we had already written that processed 1 request, and we just simply hooked it up to a queue system, okay? We also created a really nice public API. So if, for instance, we went into the game manager and went into the bird died, so this is the end of the game, what we could do is we could go toast manager dot request, toast manager 3 dot request. Let's say like rip. There we go. It's that easy to write a line of code to send a message to the player, okay? And no matter how much we spam the messages, they're all going to get through. Okay. So the singleton pattern, its main purpose is just to guarantee that there's never more than 1 instance of the class that it's in. So this singleton pattern right here, this block of code and this 1 variable will guarantee that you will never, ever in your game have more than 1 Toast Manager 3 class or instance, okay? Which is what we want. because we don't want multiple Toast Manager 3s to be running at the same time. I'm not even sure what would happen. They'd probably all be fighting and trying to run messages at the same time. It'd be a disaster, okay? When does start ever get called for the singleton? It gets called like any other game object, right? This is just a start function in a component, which means when the game starts, when this game object instantiates and loads, this is going to run, okay? Just like every other component you've written so far. The biggest advantage of singles don't support inheritance. If it's not attached to a game object, yes, that's right. This component won't run if it isn't attached to a game object. But a component that isn't attached to a game object doesn't mean very much itself anyway. So Unity wouldn't complain, but it would look probably hideous, right? So you have one shared resource, which is our panel, right? Our panel game object. There's only one of them, right? It's, hold on. It is this thing, okay? It's this. There's only one of them in existence. And if you have 3 different Toast managers that are all trying to put it into the right place at the same time, ooh, it's not going to go well. Yeah, it's not going to go well. But anyway, I hope we're not done. We're not done with the system yet. We're going to get into callbacks on Wednesday, which are super useful. We're going to get into event-driven programming, and it's going to make your lives a lot easier, I think, on Project 1 and P2 and P3 as well. However, I hope that this short and very quick example has kind of showed you how you can build a pretty hardy system that just works and can process requests in a very formal way that won't allow it to mess up. I'm not sure if I was trying to glitch out this system, I'm not sure how I would do it. Like I can spam requests as fast as I want, but the system just takes them like a champion and shows them as they should, right? Processing each one. I think what you could probably do is you might want this system to be like, whoa. If my queue gets too big, I should probably like chop it down. But I mean, yeah, it's pretty hardy and hard to mess up now. You could add additional features to the system. Like maybe instead of sending in a string in terms of a request, we could have a public class toast request, okay? And this toast request can have a string message. Oh, but it can also have a public color, text color. And oh, it can also have a callback. So public system.action, unfinished callback. And we can send in this instead of this string, right? You know, we could do something like that and make the system as complicated as we want to and as flexible and expressive as we want to. But as it stands, like this is a really effective system. It's just going to work. So anyway, okay, we're at 4:20. We're actually past that. So I'm going to stick around for about 5 more minutes. I'll turn the music on. Please ask any questions you want, and we'll get them answered. Okay, thank you so much for joining us. I hope this has been a little bit useful. Think in terms of small components that do small jobs that are easy to understand and do them well and flexibly. And also think, okay, when a bunch of components won't do the job, think of a singleton system like your Toast manager, where there's only going to be one of them, but no matter what you throw at it, it's going to be easy to use. It's going to just work, okay? And it's going to look beautiful doing so, okay? So try and think that way. Okay, do we have any questions? I need to refresh my chat here. Okay. Is using something like this to serve up game objects or sprites to other scripts? I'm not sure. Is that a question? I don't really understand. We talked about the player manager example before we started coding here, right? The idea that you might want to have a player manager system in a multiplayer game that is responsible for taking in a player number and a position and making sure that that player gets to that position, spawning it in. I mean, yeah, that would essentially serve up a game object. That would instantiate a new player game object. It would load the right models and aesthetics. It would set it up just right. and then it would enable player controls for that player, and then boom, its job is done. So it's very easy to imagine a singleton system wanting to spawn other game objects. In fact, last night I was working on a dialogue system for the Goodbye Groundhog game that does just that. It spawns a game object representing each character so that the characters can fly around and be unique and separate from the other characters. And it spawns like up to 30 game objects for every new line of dialogue. So the answer is yes. This happens all the time. I'm going to throw the music on. You can download these projects from the lecture plan. Don't forget that if you're confused. Take care, Ish. Bye-bye. Thank you for your help. So, one of you asked, what situation would you ever be in where you would want a singleton versus a static class? Yeah, static classes do not allow you to use the inspector, which is a big deal, okay? If you go with a purely static class, which can still be useful, you will never ever be able to drag and drop something in. You won't be able to customize any values for that system in the inspector. You won't be able to use the animation curve system. You'll be extremely limited. So singletons, particularly in the Unity environment, are extremely useful because game objects are extremely useful. Okay, that's been 5 minutes, everyone. Thank you so much for joining us. I hope you have a fantastic Wednesday, or Monday and Tuesday, and Wednesday when we see you again. Take a little bit of a break if you can, but not too long of a break. Try and get back at it on Tuesday. And we wish you luck with this early part of P1 Alpha. Take care, everyone. Bye-bye.